All right, with our ice cream example, we had a real value from USDA of 4,135,176,000 pounds. And we estimated using our different methods. The best one ended up being the forecasting model. That model gave us 4,154,946,475 pounds of ice cream produced. Now, how accurate, how precise is this value? Should we keep all the digits? Should we round to the nearest 100 million? So 4.2 billion instead? Why does this matter? Aren't they pretty much the same number? Well, actually, the final number should give other people an idea of our level of confidence in the result. If we report 4.15 billion pounds, then we are telling people that the real value could be anywhere from 4.145 billion to 4.154 billion, right? Because of rounding. So how many digits should we really use? This is where we need to track our significant digits. If you remember significant figures from math class, maybe even high school, as we are going through our calculations, we need to use all of our digits that are available, and then we round to those significant figures at the end. Let's talk briefly about what significant figures are and how we count them. So significant figures show the degree of uncertainty. Significant figures explain the level of precision of the measuring device. So, for example, you step on a scale and it displays 130.3 pounds. Your scale is precise to the tenth of a pound. This means that you could actually weigh anywhere from 130.25 pounds to 130.33 pounds. But your scale doesn't measure to that degree, and so it rounds up or down. We are uncertain about what comes after the 10th place. With significant figures, all non-zero digits are significant. Zeros between non-zero digits are significant. Trailing zeros that are also to the right of a decimal point are significant, but all other zeros are not significant. A quick mental test here to see if you can count the number of significant figures, sig figs, in this list of values here. So take a moment to look at these values and determine how many digits we should count. All right, did you get it? The answers are, this first one, how many sig figs? There's just 2 here. All these zeros to the left of our non-zero digits are not significant. How about the next one? We've got some zeros in there. They might trick you, but there are 6 significant figures here. These zeros are sandwiched between non-zero digits. They are significant. How about the next one? This one actually has 4 significant figures. This trailing zero, the zero to the right of the decimal point, that is significant. And our last one, this one actually only has 1 significant figure. Now our trailing zero is to the left of the decimal point. It is not significant. This one was to the right of the decimal point. This one's to the left of the decimal point. So up here we count it, and down here we don't. How do we determine significant figures with a result from a math calculation? So how do we determine the number of significant figures of our final result when we've calculated it? Well, significant figures can only decrease or stay the same with calculations. We can't increase our precision of a value by manipulating it with equations. When adding or subtracting, we keep the same number of decimal places as the measurement with the least. So here our example. We have 3 digits beyond the decimal here, 1 digit beyond the decimal here. That means our final answer should only have 1 digit beyond the decimal, 159.7. This is saying that our level of confidence is in the 10th place. And you can reason this out, right? 102.9 could have been 102.85 or 102.94, but we don't know. So we have to say that we only know the value of the result to that 10th place. For multiplication, when multiplying or dividing, we keep the same number of significant figures as the measurement with the least. So in this example, we have 5.67 times 3 equals 17.01. How many significant figures should we have? What should our answer be? Well, it's going to be 20. Huh? We're rounding 17 up to 20 because we only have one significant figure here. The 3 could have been a measurement from a scale or other measuring device that does not display the 10th place. So really, we only have knowledge about one significant figure here. So our final answer can only have one significant figure as well. I want to walk you through one example calculation. This example comes from an engineering course that I've taught before, but please don't freak out. You don't need to know how to do this calculation or anything related to fluid mechanics. We're just going to use it to show how to figure out significant digits here. So the mass of particulates emitted from a smokestack at a factory are calculated using the mass flow rate equation given here. Mass flow rate equals rho density times V velocity times A area. You find that rho density here is equal to 38.5 kilograms per cubic meter. Our velocity is 2.83 meters per second, and our area of the smokestack opening there is 0.29 square meters. So considering significant digits, what should the result be? Well, we just used this equation and we're multiplying 3 different values here. So we're multiplying, we know that our answer needs to have the same number of significant digits as the least of these. You put these values into the equation and you calculate, your calculator spits out 31.59695. So how many digits will you use in the final answer? Well, here we had 3 significant figures, here we had 3 significant figures, and here we only had 2 significant figures. So our final answer should only have 2 significant figures. We're going to round to 32.